Hey guys, it's MJ, the student actuary, and we're going to be talking about Chapter 6, compound increasing benefits, and the rest of the stuff will be in their own separate video. So without further ado, let's get into compound increasing benefits. What this is, it's when you have a benefit and every year it's going to increase by a percentage. This is very useful, especially in an economic environment where inflation is quite high. You don't want to take out a policy of, say, $10,000 or 100,000 Rand, and then 10 years down the line, that's actually worth nothing because inflation has eroded its value. So, what a compound increasing variable benefit does is it compensates for that inflation. It can also be a little bit more than inflation, so that your benefit grows even some more. And they would like to do this for, geez, I don't know why you'd want your benefit to increase, other than to erode inflation. If you think of a reason, let me know in the comments section below. But that's the introduction. That's the timeline. Let's get into the mathematics. So let's start first with an assurance. So the present value is simply going to be however much the bonus is on the timeline, discounted. And the bonus, you can see, is raised to kx, which is the life expectancy. So if the person lives for 10 years, he's going to get his bonus to the power of 10, and then it's going to be discounted back. The plus 1, because we are assuming that benefits are paid at the end of year of death. So the formula for this, or the expected value, it's actually quite simple. It's not as complicated as we would have thought it would have been, because what we do is we combined this interest rate. So we combined the bonus or the variable benefit with the discount factor, and what we do is we get a new interest rate. That's why I've got the little dash over there. And this new interest rate then makes this a typical assurance policy. Interesting thing to note is that I have added this value here, okay? And this value here is to weight the fact that we raised to k here, and because it's paid at the end of year, it's k plus 1. And so we want to get rid of this 1 here. And how we do that is we move it to this side. Oh no, sorry, that's wrong. What we do, we leave this how it is. What we do is we add another 1 plus b. And how we do that is by putting it over here. And so that compensates for our adjustment on this side. So with an annuity, it's kind of like the same thing. You've got your values are increasing. This time, however, you can see that there is no adjustment factor, and that is because our exponentials are at the same value. And this is because the increase is coinciding with the discount value. So a little tip to remember is that with a compound increase, we just need to adjust the interest rate. And we do need to refer to first principles to think what's going to be included. We saw that you could have the 1 over 1 plus b factor, there could be the 1, or there could even be the 1 plus b. This you have to think about. There's no way to learn it. Well, you could learn it, but it's much better to just think it through. And then a little extra information, which we'll see in the examples below, is that if our interest rate is 0, our annuity value becomes the expected lifetime. So let's go into some examples. We're going to do an example for a whole life assurance with the compound bonus. Okay, so this is the question. Our life is age 55. He's got a basic sum assured of 25,000. A compound bonus of 1.9231% is vested at the end of each year. It's payable at the end of year of the death. Let's calculate the premium, and we've got AM92 select at 6%. Now, when you do enough of these things, you'll see that this interest rate, which at first appears to be very random, is actually very useful, because whenever we see that and 6%, we know that when they're combined, it actually equals 4%. So remember, so I hope this doesn't make you sick, if we put in 6% here and that 1 point something percent over there, we'll see our I, it gives us 4%. And that's very useful because the tables have values at only 6% and 4%. So it's a little bit of a trick to remember with compound bonus increase, is that if it's 6%, it's most likely they're going to push you to 4%, and if you're 4%, the interest rates will most likely cancel, which we'll see in the next example. But for now, this is the answer to above. You can see we've got our premium. The premium is still at 6% because there's no bonuses are affecting the premium. Premium is paid in advance, which is obvious from our earlier videos. And here we can see I've made it dark blue to indicate that it's now at 4%. We've got the adjustment factor, and so that's our premium. Here you can see premium is always paid in advance, or most likely, makes sense. Otherwise, you'd take out a policy and then cancel it at the end of the month, and you've got 1 month free insurance. So that's always paid in advance. And here, why have we got this factor here? Well, because the benefit was paid at the end of the year. If it was paid immediately, how would that look? I'll let you guys think about that. And then last example is we're going to look at an example of a whole life annuity with a compound increases. So here's our question, payable annually in arrear, that means at the end, not in advance. Life is age 65. First payment is 5,000, increased by 4%, calculate the expected present value, and they've given us this mortality table and 4% interest. Interestingly, this value here does have those E's, which are showing the 4%, as we're going to see, that's going to cancel. So from first principles, we draw it out. You could start with the timeline. But you'll see very quickly that if you take out 5,000 V, you're going to be left with 1 plus 1 plus 1 plus 1. Okay, so like I showed in the beginning, that just gives you E65. But now they don't tabulate E65, so this could be the trick of the question. A lot of people will be like, oh, what do I do now? They do give you for E complete, the little circle, and then we just need to adjust it for the quotate, subtract a half, and we've got our answer. Okay, so in case you didn't get why subtracted a half, let's look at the tip here. So E065 is equal to A65 at 0%, and this is tabulated. To get to E65, we need to subtract 0.5. Sorry, that isn't tabulated, that is, we need to make the adjustment. And this is why we need to make this adjustment is because we only receive payments if the person is alive at the end of the year, and if you live for half a year, you're not going to get half that amount. You only get it if you complete the year. So yeah, that is a compound increase. I am going to make another video for simple increase. So click on that. I might not have a link, so just search for it on my channel. And this is just like a little, you can see it gets a lot more fun. But yeah, let me make that video now. Cheers, guys.